You drop a coin into water and it sinks straight to the bottom every time, without fail, and yet somehow a ship made of thousands of tons of steel floats. Not just floats, it carries hundreds of thousands of tons of cargo across entire oceans. Your brain knows something is wrong, and it is right to be confused because the real answer is far stranger than you think. The coin and the ship are both metal. Steel is roughly 8 times heavier than water, so how does something 8 times heavier than water sit on top of it? The answer is not in the material. It is in the shape, and the shape hides one of the most counterintuitive forces in all of physics. Go back 2,300 years, a king named Hiero. The second ruled ancient Syracuse. He suspected his goldsmith had swapped some gold in his crown for cheaper silver. He needed proof without melting it down. He called on a man named Archimedes, a mathematician, a thinker, someone who spent his days asking why the universe worked the way it did. Archimedes was stuck. Then one day, he stepped into a full bath. Water spilled over the edge, and something clicked. Every object that enters water pushes water out of the way. The volume of water pushed out equals the volume of the object itself. He was so stunned he reportedly ran through the streets, shouting the Greek word for, "I have found it." That word was eureka. What he found was buoyancy, and buoyancy is why the ship floats here is the law. Every object in water experiences an upward force equal to the weight of the water. It has displaced. The water always pushes back. The question is whether that push is strong enough to win against gravity, and the answer depends on how much water the object can push aside. Drop the coin, it pushes aside a tiny amount of water. Just the coin-shaped space it occupies that displaced water weighs far less than the coin, so gravity wins, the coin sinks. Now look at the ship. The ship is not solid metal, it is a hollow metal shell, wrapped around a massive pocket of air when it enters the water. The entire shape, the curved hull, the walls, the vast, empty interior pushes water aside, not just the thin metal skin. The whole volume that displaced water is enormous, and it weighs more than the entire ship, so the upward force wins. The ship floats. This is worth sitting with. The ship floats. Not because it is light, it floats because it is big. Shape creates volume, volume displaces, water displaced. Water pushes back, and that upward push beats gravity in the 19th century. A naval engineer named Isambard Kingdom Brunel designed the SS Great Britain, the first large ocean-going ship built from iron. Everyone thought he was insane. Iron sinks, everyone knew that. But Brunel knew something they were all ignoring. It was never about the material. It was always about the shape, the SS. Great Britain crossed the Atlantic and proved that iron and later steel could float as long as the hull displaced enough water. Now, here is where it gets personal. Your body does the same thing, the feeling of floating in a pool. That strange weightlessness, the sensation that the water is holding you up, that is buoyancy acting on your body. Your lungs are full of air, which lowers your average density in salt water. The denser water pushes back even harder, and floating becomes effortless. Your body is just a differently shaped ship. There is one more thing. Ships have a marking on the hull called the Plimsoll line, named after Samuel Plimsoll, a British politician in the 1870s who watched thousands of sailors die on overloaded vessels. It is a simple painted mark on the side. If the waterline rises above it, the ship is carrying too much. There is not enough remaining volume to handle a storm or a rogue wave. The ship becomes dangerous. One painted line saving thousands of lives. The steel does not float, the shape floats. The steel merely holds the shape in place. What keeps the ship above water is a pocket of air surrounded by metal, and the extraordinary willingness of water to push back against anything that dares to take up space inside it. You look at a ship and you see steel. But what you are really seeing is an argument about space, a hull full of air making a claim on the ocean, and the ocean following rules set down by physics long before any ship existed, honors that claim it pushes back. It always pushes back tonight the next time you drop a coin and watch it sink, remember? The coin is not failing, it is just not making the right argument. Give it walls, give it volume, give it space to breathe, and even steel learns to float.